Hi everyone. In this lecture, I will make an introduction to clean and hexagonal architectures. Basically, by separating the layers and putting the domain layer on the center of the software will lead to a clean architecture. This can be achieved by creating a dependency rule that leads to only allow pointing inwards towards the domain layer. For this, we can use dependency inversion principle and polymorphism to invert any dependency relation. In the next lecture, I will design the components of the first microservice, order service, and show how to apply these principles. In the end, you will have an easily testable software that is independent of any external element. Clean architecture also explains the details in the domain logic and mentions about the entities to implement the critical business rules and use cases to implement the application-specific business rules. In the end, clean architecture can be thought of an umbrella that covers the concepts of hexagonal architecture and onion architecture by adding the details about the core domain logic. All these architectures concentrate on isolating the domain layer and making it the most independent and stable component. The details will be just interchangeable plugins for the domain layer. To explain the component relations, I will now go into the hexagonal architecture details. Hexagonal architecture is also known as ports and adapters. The main idea is to divide the software into two main parts, insides and outsides. The insides will be the domain layer that holds the business logic. This part will be developed first, and it will not depend on any other layer. So it should be the most independent and stable layer, as it is the heart of your software. The outside will include all the dependent layers, such as API that is called by end users, databases that is used to persist the results of business logic, a message queue or event store to send notifications to other systems, an external service that needs to be called from the business layer, or even any framework that is used in the software, such as Spring Framework. All of these outside parts are not actually your software. They should be behaved as plugins to your software. So the main principle of hexagonal architecture is to isolate the domain from any of these dependencies. It will end up with easily testable applications with isolated business logic from the infrastructure and data sources. Hexagonal architecture is invented in 2005 by Alistair Cockburn. He described it as allow an application to equally be driven by users, programs, automated tests, or batch scripts, and to be developed and tested in isolation from its eventual runtime devices and databases. Here you see two types of adapters. Adapters are the interchangeable components. Primary adapters are the ones that use the core logic that is in domain layer. They use the input ports to call the implementations that are defined in the domain layer. While the secondary adapters are implemented in the external modules, like database or message queue. In this architecture, user input is processed by one or more primary adapters and passed to the core logic, and the core logic interacts with the secondary adapters only. Then output of core logic will return to the end user using primary adapters again. realize that we use interfaces on input and output integration, and dependency injection is used to pass the implementation of the secondary adapters to the core logic, and primary adapters to the outside, such as API. There are numerous advantages of using clean and hexagonal architectures. First of all, you should understand that it is good for mainly long-lasting applications. It will allow to leave as many options open as possible for as long as possible. With such applications, you will realize that you always need to adapt for new technology changes to keep your software in a good shape. As mentioned, these changes has nothing to do with your business logic. For example, today you may use a relational database. Tomorrow you may want to adopt for another relational database, or even to a NoSQL database. In this case, by keeping your business logic separated, you will be able to easily change your data source. In a traditional layered architecture, say with 3 layers, user interface, business, and data layer, we would have all of our dependencies point in one direction, each layer above depending on the layer below. So in that case, your business layer will depend on the data layer. This will prevent changing the data layer without touching to the business layer. With clean and hexagonal architecture, all dependencies will point to the business layer, making the business layer independent of any other dependency. In the coming lectures, I will start writing our first microservice using this clean architecture. Then you will see how ports and adapters will help to reverse the dependencies and make the business logic independent. I will be using dependency inversion principle to make this happen. With dependency inversion principle and polymorphism, any source code dependency can easily be inverted, and the low-level modules, like the data source layer, will be plugins to high-level modules, like business logic. In the next lecture, I will use a diagram to explain this dependency inversion on the first microservice, which is order service. With clean architecture, you will be able to delay the implementation decisions of all dependencies, and can just implement your business logic without thinking any limitations of any data source or framework. You can even test your business logic completely by simply mocking the dependencies. Apart from that, as mentioned, you can replace any adapter implementation without touching to the business layer. And you can maintain each layer separately without affecting other layers. It will also allow to separate development and deployment of different layers and modules. Furthermore, the separated layers are naturally easier to understand because each of them focuses on its own logic. When I count all these advantages, you may think, is there any disadvantage of using this architecture? In software development, every solution has pros and cons. With clean or hexagonal architecture, the price you need to pay is writing more code. Sometimes you even need to duplicate some code, like having different data transfer objects for different layers to represent some data. Yes, you will write some more codes, but it will pay you these efforts by having a fully maintainable and easily testable application. So your application should be independent of frameworks, user interface, database, and external services. Conforming to these simple rules is not difficult, and it will save you a lot of headaches going forward. In clean architecture, the core business logic is implemented in the entity objects. Entities consist of the critical business rules of the system. For example, prior to creating an order. Validating the state of the order, checking that the total price is correct, or checking if the order is in stock are the critical rules that need to run before placing an order. One layer above the entities, you will have use cases, which handles the use cases of a system by orchestrating the entity objects. Use cases harmonizes the entities by calling them in the correct order and to achieve the critical business rules. Besides the critical rules, there could be some application-specific business rules, such as having a discount on an item temporarily, or checking if a user doesn't exceed an allowed daily purchase limit. These type of rules should be implemented in the use cases. At this point, I also want to briefly mention domain-driven design next to clean architecture. In the next section, I will cover domain-driven design in detail while implementing the domain layer of the services. Here what I want to show is that the high-level approach is the same in clean architecture and domain-driven design. Both has a domain layer isolated in the core of the system and attaching the lower-level dependencies into it, such as user interface, database, and external services. However, there is a slight difference in the domain core itself. In the clean architecture, we have entities which are the core domain elements and keep the enterprise business rules. One level higher, you see the use cases that keep the application business rules. Use cases are responsible to orchestrate and call the entities as per the use case's requirement. In domain-driven design, on the other hand, we still have the entities that has the core business rules, but this time it has an additional aggregate and aggregate root concepts. An aggregate root is the main entity that orchestrates the core business rule of the current context. This context is called as bounded context. An aggregate is a group of business objects which always need to be in consistent state. Therefore, we should save and update aggregates as a whole inside a transaction. An aggregate root is a class which works as an entry point to your aggregate, and all business operations should go through the root. This way, the aggregate root will make sure that the aggregate is in a consistent state. One layer above the entities, this time in the domain-driven design, we have domain services. This can be thought as the equivalent of use cases if we compare with clean architecture, although conceptually they are not the same. In the domain service, you should have the business logic that spans multiple aggregate routes so that they can be implemented in a single bounded context. A domain service can also include a business logic that doesn't fit to an entity naturally. Additionally, there is application service concepts in domain-driven design. Application service will expose the required business layer methods to the outside using ports. And these ports will be implemented in the domain layer itself. In the application service, we can also have the data mappings, validations, and transaction management. Basically, application service should be responsible to make any data adapter calls and gather the data to pass into domain service and entities. Remember, domain service and entities has the core business logic, and they shouldn't deal with things like gathering data, mapping the data, or validating the data. Those are the responsibility of application service. As you see, there is a slight difference on the implementation of domain logic between clean architecture and domain-driven design. I will be using domain-driven design concepts and namings when I implement the domain logic of the microservices in the implementation sections. Finally, I would like to advise you to read the Clean Architecture book by Robert Martin. This book will give you a deep understanding on how to design a software using clean architecture and hexagonal architecture. Here you see some quotes that I gathered from this book. Great, next lecture we will start designing order microservice using hexagonal architecture. So I will see you in the next lecture.